You hear transformation. Right now, you should think about reflections, rotations, or translation. Okay, fair enough? You hear reflection. What is the trigger word that goes with that? Flip. Reflections, flip. You hear rotations. What's our trigger word that goes with that? No, not quite. Too much of a trigger word. Simpler. Starts with a T, ends with earn. Turn. Okay? And when you hear a translation, what do you think of? Slide. Don't think about dilate. Okay? Dilate would go bigger or smaller. Happens later. All right, here we go, y'all. Reflection. This is almost word for word the same definition of yesterday, just to repeat it for everybody. Okay. You have what's called a line of reflection. Okay. Your line of reflection is perpendicular. That's from last week, right? Perpendicular to the points that you're reflecting. Okay. It's going to start becoming more important today and throughout this class. Perpendicular, parallel, right? Remember perpendicular. What type of angle does a perpendicular line form? A right angle. How do I know something is a right angle? 90 degrees. It's got a box up here, correct? Right with me? Okay. All right, so in this example, they wanted a reflection of point A. Okay. First off, you've got to find the distance between point A and your line of reflection. And it has to be equidistant or congruent from point A to the line of reflection and from A prime to the line of reflection. Okay? A lot of vocab in there. It's a whole googly dot of vocab. Vocab is important to this particular unit. Okay? All right. Now, here's why we go to 2.0. How exactly do we draw some of these particular figures? Okay? If you would like, you can draw or write out these steps. You do not have to. Those should be easy today. Okay? I'm not going to make you do it if you don't want to. All right? Again, the state of Georgia on our exam is not going to tell you get out a pencil and draw these things. The state of Georgia is going to say, hey, where's this step right here? Here's an image. What did I do? A reflection, a translation, or a rotation. Right? You got to know the differences in the steps. All right, so for this particular transformation, this reflection, notice what it says. Step 1. For each vertex, draw a line that is perpendicular to the line of reflection. How do I know where a vertex is? Yeah, and it forms a what? Not necessarily a right angle, but just more general. An angle, right? Or a point, correct? Remember, the vertex is the point that an angle is formed, okay? That's where you got to start somewhere. Let's start there. Notice in this triangle, each vertex, each angle has a line going through it, and it's a perpendicular line through this line of reflection. Okay? Step 2, obviously, is the difficult one. Measure the distance from each vertex to the line of reflection. Rotate the image of each vertex on the opposite side of the line of reflection and the same distance from it. Right? If I had this little triangle here, here was my line of reflection. I would take the distance from each vertex to that line of reflection. So if this was, I'm just going to make it up here, okay? If this was, that's pretty good, 3 3, and 6. Correct? Y'all with me so far? You not with me? That was step 1, right? Draw it with the vertexes. Step 2 was measuring the distances. The last part of step 2, let's go 3 more. Let's go 6 more. Let's go 3 more. Now, check it out, y'all. I have reflected that particular triangle. Is it perfect? Nope. Probably not going to be perfect. Not going to be perfect unless I'm using a straight edge and a protractor, okay? And it's really messy if we get into all that. Frankly, we don't have time to do it, okay? But if I see how step 2 is involved there, right? It's really not, it's not that hard. It's a lot harder when I don't give you diagrams and stuff like that, okay? All right, step 3, connect the images, connect the dots. Yay! Play the game, okay? Any questions on that? On reflection. On today's classwork, I forgot to put this on the slides, but on today's classwork, very top of the classwork is another diagram of this in terms of how to do it as coordinates. Okay? I'm going to move on. Is that okay with y'all? No. I'll come back if you needed to. All right, next, we talked about the translation. Translation. You move along a vector. Does each segment joining a point and its image has the same length as the vector and it's parallel to the vector. Right? A couple keywords in there, right? Parallel. Parallel always means what? Side by side. Okay, side by side forever, right? No depth do them part. There is no depth coming to that line. You got me? Okay? They are always going to be equidistant on the same plane until kingdom come. Right? Forever and ever, amen. Don't laugh, Calton. Right? Here we go. A couple of ways that I can do this. Here's some tricky things. So if there is something you should write down, I suggest that this particular part right here, I'm going to enlarge it so that we can see it a little bit better. Okay? All right. Anytime we have a horizontal translation, right? Horizontal moves which way? Left to right or up or down? Left and right. Okay? Left and right. Check it out. If my P value here, P, the pre-image was XY, and I have just a horizontal translation, I would take, for P prime, I take my X coordinate and add or subtract that value. Y stays the same. Ain't so bad, right? Okay, correct? That's for a single point. Where it gets tricky is if not only P, but I have these 3 points, and it looks like this, correct? And then for each of those points, I've got to do this, all right? You understand what I'm saying? So if I said, oh, I'll get really cool, T-O-T, okay? If I wanted to move the pot to the right, correct? I take point P and move it to the right, point O and move it to the right, point T and move it to the right. You have to see when I do this? All right? I would move each of those points to the right 8 units, whatever A is. 3 units, 6 units. If it was to the left, I move to the left 5 units, 10 units, okay? I can do the same thing with a vertical translation. And take my X values, keep it the same, my Y values, move them up and down. Then I get really, really, really fun. Okay? I move them left, right, and up and down. Left, right, and up and down. Okay? This is the one that you're going to see most common. And that's the one we worked yesterday. There's just a little bit more notes to it, I guess, today. Okay? The lines will be parallel. So if I move, y'all already come out of algebra. I'm talking about this. Rise over run, correct? Right? Rise over run. Okay? Same thing. There's a slope for P, and if I translate to get to P prime, my slope is the exact same. It has to be for it to be a translation, right? We'll give you a couple more seconds to write that down. Any questions on this so far? Told you it's 2.0. You ever seen the Truman Show? You don't even know what that is, do you? All right. You seen it? Oh, you have a question? You can't. You don't have to. It'll get really crazy difficult in some situations, though, if you don't know math behind it. You'll see today. I promise. Right? But you can understand. If you have a basic, easy, simple translation where it says, hey, take this particular square or this particular rectangle and move it 3 units to the right, 2 units down, you're good. I'm good with that. Okay? But it says translate it along the line 1, 3, and you're like, ooh. It says that, what do I do? Okay, you got me? And that's when it says translate along the vector 1, 3. You got to move it 1 and 3, 1 and 3, 1 and 3. You got to be able to talk to Linda. That's why I'm showing you this today. Okay? All right? So there is a somewhat of a purpose behind it. Or if I say, take this, take image POT and translate along the vector y equals 6. Right? You can come back to this simple diagram and say, okay, where y is 6, I would substitute b for 6 or 6 for b, correct? Move every single point 6 units back. Fair enough? All right, let me move on. We got one more, and we go. Oh, I'm sorry. Here we go. How do we draw translations? Okay. One way, draw a parallel line to the vector through each vertex of the triangle. Yeah. Measure the length of the vector from each vertex. Mark the distance in the same direction as the vertex on each parallel line connecting the vertices. I'm not gonna lie to you guys. You're not gonna do this. Okay. Probably not gonna do this until like physics. You'll take physics. Science and physics. Remember how there's a point where math and science they kind of combine with each other. Okay, we're venturing into that point as far as geometry is concerned. What's happened to me in the past is I've tried to go really in depth with this, and you lose sight of the basics. Okay, so you can do this. This is the correct way and form of how you do this. Remember that the lines have to be parallel to each particular vector. Okay, they have to be parallel. Yes, ma'am. No, yeah. Really? You're in the right place. All right. Go a couple more seconds. Our last one. I'll come back to these steps if you write down. Okay. All right. All right. Here we go. We got a rotation. Okay. Our rotation. Rotations do what? Return. Rotations rotate. Translations translate. Reflections reflect. Yeah. Right. Rotation. Okay. Notice it says about a point P from the center of rotation. Each point and its image is the same distance from P. All angles and vertex of P formed by a point and its image are congruent. What the? Yes. Okay. Big part about a rotation. We call this isometry, correct? Or isometrics. Right? Y'all remember what that was? A rigid motion. When I say a rigid transformation, everything keeps its shape and its size. Right? So if I take my arms like this and I rotate them this way, and if I have better shoulders, it would be better. Okay, if I take my right shoulder, right arm, and I rotate it what is that? Counterclockwise. Okay. Did my shoulder keep the same, or did my arm keep the same shape? Yes. Is it the same size? Yeah. Okay. Got me? Same thing with all the stuff we're doing today as far as our shapes or our line segments are concerned. All right. Here's some fancy ways that you can talk about this. 90 degrees about the origin, 180 degrees about the origin. Notice what happens. Okay. I start at P and I go 90 degrees about the origin. Which way did I go from P to P prime? I went which way? That's counterclockwise, okay? Right? Right on. Right on. Okay? Notice how you can do this through arrow notation, okay? You go from X, Y, the point X, Y, and then this point becomes negative Y, X. And everybody's like, what? All right. It's still written, you still think of this in terms of this is negative X, Y, correct? You got me? You're still moving it to the left and then moving it up. How much am I doing that? I take that original Y coordinate and I subtract that, or I take the negative value and use that as my X. Okay? And then I do the exact opposite with my Y value. I'm going to go over a few more examples of that. That can be crazy. Okay? 180 degrees, I just take the exact opposite of whatever points I have, right? My strong suggestion today, this being our first day of 2.0, take each example today point by point. Okay? Try and do things all at once and lump them all together, especially early on. Okay? If I had made this a triangle, I said I want an 180 degree rotation. Don't try and flip the whole triangle. Take it one point at a time. Okay? You got me? One point at a time to begin with. Then you'll get the hang of it and be able to do it point by point before we get there. Okay. Last thing, guys, how would we do this? Draw a segment from each vertex to the point Q. So if it has this particular angle here, start with angle A, we start with angle A, go to point Q, construct an angle congruent to angle A on each segment. What do you think, Paul? Okay? Congruent angles have what type of measurement? Identical or the same particular measurement. Okay? So in their example here, that angle measure and that angle measure is the exact same. Got me? The exact same. Measure the distance from each vertex to the point Q and mark off distance on a corresponding grade. Locate next to each vertex, connect the images above. I mean, damn, this would be cool to do on a computer too, right? Okay, but we don't have that capability here. So, although I think that you're supposed to do, if so, we don't have it yet. All right, guys, the easiest thing to do. Not that you always take the easy way in life, but in this particular avenue, I should take the easier way, right? And that is to take them and think of it as you would any type of coordinate points. And flipping my X and Y values and writing in new coordinate points. Okay? All right. Anybody, guys, anything else? Any other questions? Right on. That's all I got for today.